Okay, so this is the next step to your factoring. We've got one more after this. At this point, if you have gone through all 4 Math Excel assignments for 8.5, then you've pretty much a firm grip on the material. Even if you haven't gone through all 4, my goal overall for the last couple days was really just getting you through the 3 videos. The 4th video, as those of you who have seen the 4th can tell you, is just a little bit more specific on whenever there's an extra number, which we'll see, and again, you can always go back. I do want you today, after you watch this video, if you have not finished all of 8.5, to do the 8.5 first and then work your way back up here. But again, this is just to keep you up to speed for the couple of questions that you're going to see as review for tomorrow's quiz. But anyway, we're going to look at 2 special problems that are dealt with slightly differently. Factoring perfect squares. Sometimes whenever you get something like, let's say you factor something and you get 2x plus 1, 2x plus 1, that actually does work, but what they want you to do in some situations is, because there are 2 of these and it's a repeat, they'll write it as 2x plus 1 squared. And hopefully you saw that in your bell ringer, where that's really all it is just if that's your factors, then you can also write it this way. So that's mainly the thing that you got to look out for. It helps if you understand that that exists, because what will happen is there are certain times when you see a question like this and the numbers are a lot bigger. Try not to sneeze on camera, sorry. Okay, so looking at this, we're looking for numbers that multiply to be 36 and add to be 12. And when we look at our numbers for 36, 1 and 36 don't do it, 2 and 18 don't do it, 3 and 12 don't do it, 4 and 9 don't do it, but 6 and 6 actually add up to 12, with a positive 6 and a positive 6, where we take our 9x squared, or 9x over 6, and our 9x over 6 with the same number. Both of these, 9 and 6, can be divided by 3, giving us 3x over 2, 3x over 2. And again, with that being our answer, it means that this is our factor. Again, depending on where you are, if it is a double factor there, they actually want you to write it this way. And so on today's assignment, if you do end up with factors, on 8.7's assignment, if you do end up with factors like that, you just got to understand that they actually want you to write it this way more than that way. Now, I have seen some questions where it lets you get away with that, but if they mark you wrong, check to see if your factors are the same, and if they are, just go ahead and turn it into the squared version of it, and it should be okay. But other than that, factoring perfect squares really isn't that tough. We'll revisit this in a second in a situation that will help us out to know about perfect squares. But other than that, the real situation is going to be factoring the difference of squares. Sometimes when you don't have a middle term, it just means that you know that b is equal to 0. For example, we've learned that it's ax squared plus bx plus c, and in this case, az squared plus bz plus c. There is a squared term, there is no regular term, and there's a number. So here's your squared term, here's your number. And so if that is not there, it means that b is 0. So in our training, we know that it multiplies to equal 1 times negative 9, or negative 9, and adds to b, since nothing's there, 0. And the special thing I hope that you saw in one of your assignments at least is that there are numbers that add to be 0, and they are positive 3 and negative 3. And so you take that z and you put it over both of them, and you end up with z plus 3 and z minus 3. Although those two are out of the order that we had, that is what happens. Now remember this from before, that what happens is z times z is z squared, and then your middle term cancels out and it leaves you with a negative 9, and that is really what it is. Alright, so the difference, the only thing that happened differently is that in this problem here, when there is no, and you can kind of know it from your experience, when there is no middle term, you should have the same thing in both parentheses with just a different sign, because that is the pattern that we learned from last unit when we were doing the distributive property. So on this one, multiplies to equal 49 times 4, I think is 356, I don't know, 396, who knows, 49 times 4, 196, what was I doing? Multiplies to be negative 196, because again that's 4 times negative 49, adds to be 0. And keep this in mind, in order to add to be 0, it means that the numbers have to be the same. Now you can make a factor tree for this if you want, but if they add to be 0, it means the numbers have to be the same. Just like if it adds to be 1, the numbers have to be right next to each other. And the way that we can find out what number multiplies by itself to equal that, in my experience, is the square root. So I'll just hit second x squared 196 to see what the square root of it is, and we see the answer is 14 and 14. And so therefore, it has to be a positive 14 and negative 14. And so we put 4x over negative 14 and 4x over positive 14. Both of these numbers, sorry, the light on this is kind of bad. Anyway, both of these can be divided by 2, so you end up with 2x over negative 7 and 2x over 7, which gives us 2x minus 7 is one factor, 2x plus 7 as the other factor. And again, you know this is going to go away because these two things are exactly the same and the middle signs are different. So as you do that, keep that in mind. Again, if you have it equal 0, you do not have to do the whole tree. You're looking for the number that equals the same thing. All you have to honestly do is just go ahead and do the square root of it and go from there. Now you might want to write this for yourself, because part of what I do, although I do want to show you how things work, is to show you if there is a shortcut or easier way to do it. If you notice that b is 0 and you can identify each term as a perfect square, then you can actually use the plus and minus shortcut. I actually recommend you do it because some of these numbers will get very crazy, or some of these problems could get kind of crazy, and it'll mess you up. So write these three things real fast and I'm going to show you what I'm talking about. I recognize here that there is a B or A and a C with no B, and so I ask myself, is there something that multiplies by itself to equal 9? Yes. 3. Is there something that multiplies by itself to equal x squared? Yes. X. Is there something that multiplies by itself to equal 1? Yes. 1. And so then all I have to do is 3x plus 1, 3x minus 1. As long as it is just a squared or a and c, no b, and I can identify perfect squares here, then you can do that. Now be careful, because what some of you will do is you'll see a 6 and say 6 can be multiplied by itself by doing 3. You don't cut it in half. You literally have to know what multiplies by itself to make that number. But as long as you can identify those things, that is your shortcut. Notice how fast that is. If you saw this one, I don't know if you want to do numbers that multiply to be 1600. I guess you could, because you know the square root thing now, but this is going to be much easier if I can say, hey, this is two terms with a minus in between. It has to be a minus. And so all I have to do is say this would be 5 times 5, that is x times x, and this is 8 times 8. So this has to be 5x plus 8, 5x minus 8, and that shortcut works to your advantage. This one here, the only thing that makes x squared is x times x. Here's your two terms with a minus. 4 is 2 times 2, y squared is y times y, and then you simply take those two parts and go x plus 2y and x minus 2y. So, putting all this together and going to a more difficult version, what about if we have this, we look, we don't see perfect squares. First off, whenever you see this part here and you notice that there's no b, but then there's no b and the numbers are weird, chances are you can pull a number off. And so the first thing you should do is look to see what you can take out of 12 and 27. And there is an easy way to do that, and your calculator actually does it. Think about it. Is there anything you can pull out of 3 and 4? The answer is no, and the way you can verify that is to put 3 and 4 into a fraction and see what it reduces to be. Notice it stays 3/4. But if I put 12 and 27 in a fraction and reduce it, it turns into 4/9, which means now my only thought is, how in the heck do I turn a 12 into a 4 using division, and 27 into a 9 using division? Or you could even say, what's 12 divided by 4, or what's 27 divided by 9? The answer, of course, to that is 3. So we kind of know by now that we could probably pull a 3 out and go from there, but I want to show you, because if you pull a 3 out, it would turn into 4x squared minus 9, which you notice now is 2x, and 3, which you can then factor the way we're going to factor, as 3 times 2x plus 3, 2x minus 3, and finish that off. But let's forget about that it even exists, and do it the way that we were taught. Multiplies to equal 12 times 27, which is 324, and adds to b 0 because of course there's no b. Remember I said if it adds to b 0 that the numbers have to be the same, so do the square root of 324 and you get 18. So it'll be positive 18, negative 18, and again take this 12x over 18, 12x over 18, one of those being positive, one of those being negative. Both of these, the biggest number is 6, so it'll be 2x over negative 3, 2x over positive 3. Notice how that popped back into my problem. And so when I put those two things together, 2x minus 3, 2x plus 3, and I do my typical check, 2 times 2 is 4. I need to be at 12, and what we saw in our fourth video is that whenever this multiplies to be 4 and I need it to be higher, just simply put that factor outside. 2 times 2 is 4, times 3 is 12. 3 times 3 is 9, times 3 is 27, and there you go. Alright. The very last question is just a matter of making sure you understand that you can work forwards and backwards sometimes to solve these things. It's a puzzle, and sometimes to solve a puzzle you have to kind of go the opposite direction. And so what I'm looking at here is, I don't know if I want to find numbers that multiply to make 3,136 and add to be 112. What I would do instead, if I see this question, before I even work it out, is I am going to do the square check real fast. This is 8x. This is 7. That's minus, so I'm going to check real fast to see if this actually is just a perfect square being multiplied by itself. And so I go 8x times 8x, of course, is 64x squared. 7 times 7 is a positive 49. Those two things work out like we need them to. The question is, do the middle terms make 112? And we know from doing the distributive property that we take this times that to get negative 56x. This times that to get negative 56x. And notice that adds to make negative 112x, which means that this has to be it. So we can just simply say 8x minus 7. 8x minus 7 instead of doing all that work to find numbers that multiply this to make this huge number. Now you might have to do it. That would just be mean, but you might have to actually do it. But if the numbers get outrageous, chances are it's just a perfect square. If you check and then just verify it, chances are it's just a perfect square that you can just go ahead and put this way, or as we learned earlier, this way. Alright, so again, if you did not finish the 8.5 work, go back to that now and take care of that. If you did not finish the quiz, go ahead and take care of that now, because this quiz tomorrow is not going to have a lot of these questions. It's going to have more of the 8.5 questions. So finish the work from 8.5 first and then do the Math Excel for this, and that is my direct instruction for you. If you are working on 8.7, that means that everything in 8.5 is complete, so make sure you do that. I will be checking the grade books to make sure that you're doing what you're supposed to be doing. So as I said, if you're having any issues, question it. You just can't ask any questions on the quiz, and please make sure you're not cheating on that quiz. Other than that, good luck.